Good morning, everyone. Welcome back. Thank you for joining us. We're going to try and get you through this Monday morning. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yes, and we are talking once again about our favorite telescope and our favorite, probably our mutual favorite subject on these shows, and that's space and the James Webb Space Telescope.
Yes,
and
sir.
What it's seeing out there.
Yes, sir. Astronomers using the James Webb Space Telescope have uncovered surprising evidence about how enormous super Jupiter planets are born. So if you think of Jupiter or Saturn, big planets, planets, right? These are super Jupiters, 5 times as big. The discovery blurs the line between massive planets and brown dwarfs, the objects often called failed stars. Researchers led by the University of California, San Diego, use observations from the James Webb Space Telescope to investigate this mystery in the HR 8799 star system. Their findings, published in Nature Astronomy, point toward an unexpected answer. Would you like to know more?
Okay, gas giants are enormous planets made mostly of hydrogen and helium. Even though they likely contain dense cores, they do not have solid surfaces like Earth. In our solar system, Jupiter and Saturn are the best known examples, but astronomers have discovered many giant exoplanets beyond our solar system, including some that are far larger than Jupiter. That's hard to believe, really. The biggest of these worlds begin to overlap with brown dwarfs, objects often described as failed stars, as Steve mentioned earlier, because they do not sustain hydrogen fusion.
Right there, yeah. Okay, scientists have long debated how these gas planets form. One theory, known as core accretion, suggests that rocky and icy material slowly gathers inside a disk surrounding a young star. Over time, this growing core becomes massive enough to pull in huge amounts of gas, creating a giant planet like Jupiter or Saturn. Another possibility is gravitational instability, where part of a gas disk rapidly collapses and forms a massive object in a process more similar to star formation.
The HR 8799 system sits about 133 light years away in the constellation Pegasus. Its planets are enormous, ranging from 5 to 10 times Jupiter's mass. That is huge.
Yeah.
They orbit very far from their host star at distances between 15 and 70 astronomical units.
So I think 1 astronomical unit is the distance from Earth to the sun. I'm pretty sure that is.
Okay, well, that's pretty far.
Yeah.
So, all right. Even the innermost planet is 15 times farther from its star than Earth is from the sun. The planet masses range from 5 to 10 MJ UP or MJ up.
Kind of like megajupe is what I'm thinking.
Megajupe, okay.
Yeah.
Meaning the smallest world in the system is still 5 times more massive than Jupiter. That's big. That's a big solar system.
You did say helium, is that right, Scott?
Really?
Or did you say hydrogen? Was it helium or hydrogen?
I think I said helium. I don't know what I said. Smurf, Mr. Papa Smurf.
Sheriff was blowing up balloons yesterday for Cameron's promotion, and I told Cameron, "Bring me the helium tank." I took a huff.
Did your wife know you're doing that?
Get out of there.
Yeah,
we're broadcasting. Get out of here. You don't get paid.
Hey, there's only room for one Smurf in that family, Cameron.
Astronomers often describe HR 8799 as an oversized version of our solar system because it contains 4 outer giant planets, similar in arrangement to Jupiter through Neptune. However, the planet's extreme masses and wide orbits create a problem for older theories of planet formation. Traditional core accretion models suggested planets this massive would not have enough time to form before the young star cleared away the surrounding disk of gas and dust.
Okay, what's the difference between a gas giant, brown dwarf, and star? It comes down to a few factors. Are we gonna go every other one on these?
Yeah, every other one. So take this first one.
All right, the first one is mass. Stars are the most massive, 80 MJ up plus, then brown dwarfs, 13 to 80 MJ up, whatever that is, MJ up. Then gas giants, below 13 MJ up. MJ up equals 1 Jupiter mass. So, okay, I get that. So that's big.
Processing power. Stars fuse hydrogen, which produces intense heat and light. Brown dwarfs confuse deuterium, which produces much less intense heat and light. Gas giants have no nuclear fusion.
Formation. Stars and brown dwarfs form through the direct collapse of an interstellar gas or cloud of gas and dust, while planets form in the disk of material surrounding newborn stars. Planets first accrete teeny or tiny pebbles,
Teeny tiny.
teeny tiny, to form a core, which is then followed by runaway accretion of the surrounding gas to form gas giants.
Yeah, and this isn't overnight. This takes a while. This takes a long millions and billions of years. To study these distant worlds, astronomers use spectroscopy, the analysis of light, to determine the composition and properties of objects in space. Before James Webb Space Telescope, scientists mainly relied on ground-based telescopes to measure molecules such as water and carbon monoxide in exoplanet atmospheres, but researchers eventually realized that molecules containing carbon and oxygen are not the best indicators of how planets form because their origins are difficult to trace.
Instead, the team focused on more stable materials known as refractory elements. Sulfur is one of these elements and exists only in solid material within the protoplanetary disk where planets take shape.
How do they know that? How do they know it? It
I don't
only exists there.
I have no idea. I don't know. I guess they're smarter than we are. Or they, well, never mind. Finding sulfur in a gas giant atmosphere strongly suggests the planet formed through core accretion.
Quote, with its unprecedented sensitivity, JWST, James Webb Space Telescope, is enabling the most detailed study of the atmospheres of these planets, giving us clues to their formation pathways. With the detection of sulfur, we're able to infer that the HR 8799 planets likely formed in a similar way to Jupiter, despite being 5 to 10 times more massive, which was unexpected, said Jean-Baptiste Rufio, a research scientist at UC San Diego and first co-author of the paper.
HR 8799 is also relatively young at about 30 million years old. That was for reference. Our solar system is about 4.6 billion years old. Young planets remain hotter and brighter than older ones, making them easier to study with spectroscopy.
James Webb Space Telescope spectrograph provides extremely high-res observations from space, avoiding interference from Earth's atmosphere. For the first time, astronomers identified detailed signatures from several rare molecules in the atmospheres of the system's 3 inner gas giants that had previously remained hidden.
Okay, the discovery required overcoming major technical challenges. The planets are about 10,000 times dimmer than their host star, and the James Webb Space Telescope's spectrograph was not originally designed for this kind of observation. Rufio developed new data analysis methods to separate the faint planetary signals from the overwhelming starlight. Jerry Juan, a 51 Pegasi B fellow, whatever the heck that is, at UCLA, built advanced atmospheric models to compare against the JWST observations and determine whether sulfur was present.
The clearest evidence of sulfur appeared in the planet HR 8799c. As you recall, they're lettered from the sun, from their sun. So C is the third planet from their sun. Although researchers suspect sulfur exists on all 3 inner planets, the team also discovered that these planets contain more heavy elements, including carbon and oxygen, than their planet's parent star. That enrichment provides additional support for the idea that the objects formed as planets.
According to Rufio, HR 8799 remains unusual because it is currently the only directly imaged system known to contain 4 massive gas giants. However, astronomers have identified other systems with even larger companions whose systems are still uncertain. Scientists are continuing to search for answers by studying more planetary systems across the galaxy. There you have it. Okay. I can't believe it. I mean, Jupiter is the largest planet in our solar system, I believe.
That's why it's called Jupiter.
And it is large. When you see a picture of it next to Earth, it's big.
Earth's teeny tiny.
Yep. So, and
like a marble in a basketball.
Yeah, 10 times that's man, you don't want to be running into that or have it run into you. That's a big boy.
Yeah, it's interesting. I mean, those could eventually turn into stars. You know, they're so big.
Yeah.
Maybe in 1 billion years it might. Who knows?
Maybe so.
All right, folks. Okay. Thanks for joining us. We'll catch you in the afternoon.
Thanks, everyone. We'll see you this afternoon.